All right, so we're going to ultimately talk about some derivatives of natural logarithms here. And I just want to refresh our memories a little bit about the algebra portion of this. So, a couple things. First of all, remember that the natural log of x, that's the same as log to the base e of x. So we have all of our same log rules apply to natural logs as well. The other thing to remember is that if I've got the natural log of x equals y, if I switch that to the exponential form, it becomes e to the y is equal to x. This is important to remember because it helps actually keep track of these rules, right? If we're saying that the natural log of 1 is 0, that's saying that when x is 1, y is going to be 0. The reason is because anything to the 0 power is 1. If I were to switch this into the exponential form, it would be saying that e to the 0 power is equal to 1. Right? Matching up with here, my x value is the 1, it moved over there to there, and my y value is the 0, so it went up top. Well, this is true for anything. No matter what number I put, raised to the 0 power, the answer is always going to be 1. So that's where this rule is coming from. Same things kind of go with these. So you can see that these values in here are treated somewhat like exponents because they would be in this location if we switch to the exponential form. And so if I'm taking the natural log of two things being multiplied together, we know that if we multiply two numbers that have exponents, so if I had like, e to the 5th times e, I'll put a squared on there just so I don't have to deal with the one that's not written. I would add these. This would be e to the 5 plus 2 power, right? That's the same thing that we're saying here. It's just in a log form now. So we're saying that the log of a times b, it's the same as the log of a plus the log of b. Same idea here. If I had e squared cubed, I would be multiplying these exponents. This would be the same as e to the 2 times 3, right? And so what we're saying here is that if I've got an exponent here, n, I can bring it in front and have it be n times the natural log of a and end up with an expression like that. And then lastly, same idea here, if you have division, if I've got e to the 5th divided by e squared, this answer would be e to the 5 minus 2 power, would be e cubed. Same concept going on here. If I've got division in my natural log, I can expand it into a subtraction problem.